this is the last lesson in Unit 2. And this absolute value inequalities combines what we learned from the compound inequalities. If you remember, we talked about the great or statement and the less than sandwich last class. Well, this time they don't start as a great or statement or a less than sandwich. You have to rewrite it as one of those compound inequalities. So the key to this is to rewrite an absolute value inequality as a compound inequality. Okay. It's also going to combine what we talked about with absolute value equations, where absolute value always has two numbers with the same distance. So there's always two equations that we write with absolute value equations, and those two equations are what we actually solve. Well, this time we use the two numbers that are the same distance from 0 as the two boundary numbers that we use for the compound inequalities. So, for example, anything with the greater than sign, it could also be just strictly, the absolute value of x is greater than 5, but as long as it has absolute value with a greater than or an absolute value with a greater than or equal to, I call it the great or statement. Okay. And if you remember, when we did compound inequalities, the great or statement, the graphs went in opposite directions, like the shaded part went in opposite directions, whether there were open or solid points or a combination of both. And all you have to do is you look at this guy and you say, okay, well, we want to find all the numbers that have an absolute value greater than or equal to 5. Well, I start with the boundary number, and you say, okay, well, what two numbers have an absolute value of 5? Well, I know -5 and 5 are 5 units from 0. So basically, all we have to do, and we're going in two different directions. You're always going to go less than the negative boundary or the negative number, and you're going to be greater than the positive number. This is what I mean. We rewrite this into two statements. We rewrite it as x is less than or equal to -5. You always do less than the negative boundary, and we keep the or equal to sign because the original problem had the or equal to. Then we put or, and this is the word play that I use, because greater, the ER, I basically separate it as the great or, meaning that it's the longest problem. And then we just write it without the absolute value, x greater than or equal to 5, and this is what we graph. So we graph each part on the same inequality. So we find -5, we're going to put our solid point. And for the first inequality, it's pointing to the left. And for the second inequality, it's pointing to the right. And if you look, if I choose any number, let's say +10, I could put +10 inside the absolute value, and we know the absolute value of 10 is greater than 5. Well, since this arrow is going to continue going on, +10 is part of that shaded solution. So anything that's in the arrows, the shaded area, is a solution for x. It could also be -10. So if I put the absolute value, if I put in -10 for x, the absolute value of -10 is 10. Well, we know 10 is greater than 5. In fact, let me write that in. I could replace -10 for x, and that still would be greater than or equal to 5 in the original, because we know the absolute value of -10 is 10 units from 0, and that's still greater than or equal to 5. So that's why the negative numbers work in this case. That's why we rewrite it as a great or statement, where you always use the less than sign with the negative boundary and the greater than sign with the positive boundary. And I'm talking about the two boundaries are the two numbers that are 5 units from 0. So With the absolute value, there's always two numbers with the same distance. Okay? Now, case 2 is the less than sandwich in the compound inequalities. So this is your less than sandwich. And if you remember, the less than sandwich always had the x in the middle with the less thans on either side. And in this case, since we have the or equal to, we're going to throw in the or equal to. And now we just use the two numbers that have an absolute value of 8. Well, we know the two numbers that are 8 units from 0 is -8 and +8. And then, boom, there's our less than sandwich. So when we go ahead and graph it, we go ahead and put our solid point on -8 and a solid point on +8, and we just shade in the middle. So we create our sandwich graph. Okay? And the trick is, if you have an absolute value with a less than sign, it's always going to be a less than sandwich. Okay? So, we're not going to worry about this part of the notes. We're going to go into the examples. So right away, number 1, I recognize it's a greater than or equal to sign. So we have an absolute value, which always tells me there's two boundaries. There's two numbers with an absolute value of 4. Combined with the greater than sign makes the great or statement. So I have to rewrite it as x is less than or equal to the negative boundary, or x is greater than or equal to the positive boundary, because both -4 and 4 are the two boundary numbers that are 4 units from 0. And that's where absolute value always has two equations or inequalities. Okay, and so then we can go ahead and graph this. So we find our -4, we put our solid point, and then we're going to shade everything to the left for this first inequality. And then we have our +4 solid point, and it's pointing to the right, so we shade everything to the right. And then we go ahead and do our interval notation, and we just read the graph from left to right. So if you follow my eraser, first thing I'm going to hit is the arrow that keeps going to -infinity, and we always put parentheses on the infinities. It stops at -4, which is a solid point, so we use a square bracket. Remember, this gap means the word or, but we use the union sign. And then as soon as we hit the solid point, we use the square brackets on the 4, and it keeps going, and this arrow is going to keep going to +infinity. Okay. All right, so number 2. Pardon me. So as soon as I see the absolute value, I know there's two boundary numbers. And the two numbers that are 7 units from 0 are -7 and 7. And as soon as I see the less than sign, I think, oh, it's a less than sandwich. I keep the x in the middle with the two less than signs. I don't need the or equal to this time because the original problem doesn't have the or equal to. And I just use the -7 and the +7. And we always put them in order. The negative boundary goes on the left, the positive boundary goes on the right. And there's nothing to solve, so we just go ahead and say, okay, it's between -7, we do an open point, and +7, it's an open point, and shade in the middle. And then our interval notation is just from -7 to 7, and we use the parentheses on both since both are going to have the same open point. Now you start to see that we don't just have plain x like we do in number 1 and 2. We have operations like -1 plus 2 multiplied by 3. So we're gonna, once we set these two situations, either the great or statement, less than the negative or greater than the positive, or we write the less than sandwich with the negative on the left and the positive boundary on the right, we might have to solve for x. Okay, so like at number 3, the absolute value of x -1 is greater than 6. Well, first thing you need to notice is the absolute value tells you there's two boundaries, -6 and +6, because there's two numbers that are 6 units from 0. So Also, there's a greater than sign, which tells us it's the great or statement. So we're always going to write the two inequalities, where we have the negative boundary and you use the less than sign because we need it to be going to the left. And then we do the positive greater than the positive because we need the graph going to the right, and that's where there's a gap. So we're going to take the stuff in the middle and we're going to say x minus 1, that never changes, is going to be less than the negative boundary, or the stuff in the middle, which doesn't change. The absolute value does not change it to a plus, because we're not taking the absolute value, we're just looking at the stuff in the middle. Or the x minus 1 is greater than 6. Well, in number 1, it was also a great or statement. The only difference is we didn't have to solve for x. Now we have to finish solving for x. All we have to do is add 1. So we get x is less than negative 5. Or, when we add 1, x is greater than 7. Now we have our full answer as the written inequality answer. Now we have to graph it and write our interval. So the first part, we find our negative 5. We know that we need an open boundary because it's just strictly less than, and you shade to the left. Or is going to be our gap, so we go to the other boundary, which is positive 7. So you have an open circle and you shade to the right. Now we do our interval notation. Again, if you follow the graph from left to right, first thing my eraser hits is the arrow, which shows it's going to keep going to negative infinity. Then it's going to stop at the open point at negative 5, so we just use the parentheses because it's an open point. Union, which is the or, represents the gap. Then we pick up again at the positive 7, but it's an open point. And then the arrow tells me it keeps going to positive infinity forever and ever. Okay, so let's look at number 4. Well, right away, the absolute value, the first thing you should recognize is with the absolute value, there's going to be two boundary numbers. And two numbers that are 7 units from 0 are negative 7 and 7. And so we could put negative 7 and 7 inside that absolute value. Now, because it's a less than or equal to, I automatically think, oh, it's case 2, it's a less than sandwich. So I'm going to write negative 7 is less than or equal to, yeah, because it has it, x plus 2 is less than or equal to 7. You always take the stuff in the middle. Now, the only difference between number 2 and number 4 is the fact that you have the x plus 2 instead of just the plain x. Well, from what we learned in our last lesson on compound inequalities, to solve for x in the middle, we need to get rid of this plus 2, and we can't just do it on two sides. We have to do it on the left, the center, and the right. So we're going to subtract 2 on all three sides. So we get negative 9 is less than or equal to x is less than or equal to 5. And then that's our solution that we're going to graph as a less than sandwich. So we have negative 9, and that's a solid point. And then to positive 5, and that's also a solid point. And because it's a less than sandwich, we shade in the middle. It's kind of like we're creating a sandwich. And then our interval notation is just from a solid point on negative 9 to positive 5, and they're both solid points, so we're going to use 2 square brackets. Okay. I'm going to have you do 5 on your own. Okay, let's do number 6 together. So again, first thing I notice is the absolute value, so I know the two boundary numbers are negative 3 and 3. And it's a greater than sign, so I know to do the great or statement. So I take the stuff in the middle, the 2x plus 5, and I do less than or equal to the negative 3, or the 2x plus 5 is greater than greater than or equal to, because if there's an or equal to, they both will be in or equal to. Now we just solve, we have 2 steps on each one. So we're going to subtract 5 on both sides. So we get 2x is less than or equal to negative 8, or 2x is greater than or equal to negative 2. And because the coefficient on the x is positive, we're going to be dividing by a positive on both sides. So we do not flip the inequality at all. We keep the inequality the same direction. I'm just going to write the answer up here. So we get x is less than or equal to, and then negative 8 divided by 2 is negative 4, or, and then these divide out, so we get x is greater than or equal to negative 2 divided by 2 is negative 1. So this is the answer for the written inequality. We graph it, so we just graph each piece on the same graph, and there's going to be a gap because of the or. So here's our negative 4. We do our solid point on the negative 4, and we shade to the left, because the less than sign with the variable on the left, okay, points to the left. Or we go to negative 1 with our solid point, and the greater than sign points to the right. Since we have the variable on the left, we can do that. Now our interval notation, so we just go from negative infinity to negative 4. We put a solid or a square bracket on negative 4 because it's a solid point, union. We have, the union is our or, which is the gap. Then we have negative 1, which is a solid point, to positive infinity. Now, 7 through 12, these are considered to be my honors type question. And what I mean by honors type question, if you're interested in getting an honors geometry recommendation from me, you're going to have to be able to master not only the 1 through 6 problems, but you'll have to master these problems. So what I mean by this, if you remember from the absolute value equations lesson, we had to isolate the absolute value before we could write the 2 new equations. Well, guess what? It's the same thing. We have to isolate the absolute value before we can write the great or statement or the less than sandwich. So in other words, we have to get rid of all the stuff outside of the absolute value before we can do one of the compound equations, compound inequalities. So before I even think about numbers with the absolute value, I need to get rid of this minus 1, because that minus 1 needs to be with all the other constants outside of the absolute value. So we have the absolute value of x plus 3 is less than 6. Now I can say, oh, it's a less than sandwich. And I know because of the absolute value, we have the two numbers, the two boundary numbers that are 6 units from 0 are negative 6 and 6. So I write my less than sandwich as negative 6 is less than the stuff in the middle, which is x plus 3 is less than 6. And now all I have to do to finish solving for x is subtract 3 on the left, the center, and the right. So then we get negative 9 is less than x is less than 3. So this is the inequality or written answer. So we go from negative 9 to positive 3, and they're both open boundary points, and you shade in the center. Then our interval notation is just from negative 9 to 3. Okay. Now if you look at number 8, all you have to do is divide by 2 to isolate the absolute value. We never ever distribute in absolute value. So this actually becomes the absolute value of 2x plus 8 is greater than or equal to 6. Now we can talk about what the two boundary numbers are. We can't talk about the two numbers that have the same absolute value until we isolate the absolute value, which means anything that's outside, we just have to do the opposite operation to get rid of it. So now I know the two boundary numbers are positive 6 and 6, since both positive 6 and 6 are 6 units from 0. And it's a greater than sign, so I'm going to do the great or statement, which is always going in two different directions. So we have to do less than the negative 6 and greater than the positive 6. So we have the stuff inside, 2x plus 8 is less than or equal to negative 6, because we need the graph to be going this direction, or the 2x plus 8 is greater than or equal to 6, because we need this part of the graph that's split to go this direction. Okay. the less than sign is always with the negative boundary, and the greater than sign is always on the positive boundary when you rewrite your absolute value inequality as a compound inequality with the greater than sign. So now we just do 2 steps. We're going to have to subtract 8 on both sides and then divide by 2 on both sides, just like we've been doing with our equations. So you get 2x is less than or equal to negative 14 on the first one, and you subtract 8 on both sides, so you get 2x is greater than or equal to negative 2. Because the coefficient of x is positive, when we divide by 2 on both sides, we don't flip it. We don't flip the inequalities because we're dividing both sides by a positive. So you get x is less than or equal to negative 7, or x is greater than or equal to negative 1. So here we've got our inequality. Here's our negative 7 with a solid point. We shade to the left, and then negative 1, we put our solid point and we shade to the right. And then our interval notation is negative infinity to negative 7 with a square bracket, union, square bracket, negative 1 to positive infinity. So sometimes, like number 11, you're going to have to do 2 steps to isolate the absolute value. So before we can write it as a compound inequality, we have to add 3. So we have the absolute value, or 10 times the absolute value of x minus 4 is going to be greater than, or just greater than, 50, oh boy, I'm having troubles today, 47 plus 3. We still have to divide by 10 because 10 next to the absolute value means multiplication, but we cannot distribute. We have to divide it to get rid of it. So we get the absolute value of x minus 4 is greater than 5. And then right away, now that the absolute value is all by itself, I can find out the 2 boundary numbers that are 5 units from 0, which are negative 5 and 5. So and it's a greater than sign, so I have to do the great or statement. So I take the stuff in the center, x minus 4 is less than negative 5, or x minus 4 is greater than 5. So I add 4 to both sides, and I get x is greater than negative 1, or x is greater than 9. And then I just graph. In fact, I think I'm going to have you do, at this point, you should be really good at graphing and the interval notation, and if you're not, you need to come see me during class and get help. So, actually, I want to look at number 10. Notice the only thing I have to do on number 10 to isolate the absolute value is divide by negative 9. Well, as soon as we divide by a negative, we have to flip the inequality. So the absolute value of x minus 3 is actually less than, because we have to flip it, positive 5. So it may have looked like a great or statement when it started, but we can't tell what kind of compound inequality it is until we isolate the absolute value. Well, now we realize, okay, absolute value is isolated. The 2 boundary numbers that are 5 units from 0 are negative 5 and 5. And the less than sign tells us to do a less than sandwich with the stuff in the middle. So x minus 3 is in the middle. Oh, sorry, we don't need the absolute value anymore. Is less than negative 5 and less than positive 5. So it's in between those. That's why it's sandwiched in the middle. And all we have to do is add 3 to all the sides. So we get, well, negative 2 is less than x is less than 8. Okay. So then we have negative 2 as an open point, and then we have positive 8, and we shade in the middle because it's a sandwich. And our interval notation is from negative 2 to positive 8 with parentheses since they're all open circles. So for number 3, you should get x is less than negative 4 or x is greater than 4, and then have the matching graph and interval notation. And then For number 4, you should get x is less than or equal to -1 or x is greater than or equal to 5 with the matching graph and interval notation. And I wanted to mention I copied the wrong symbol over here. So it should have been, and you probably might have been confused about this when you first watched the video or the previous part of the video. It should be x is less than -1. So if you thought that, you were correct and good job. Or x is greater than 9 like I had. So you should have the matching graph and interval notation. So just check to make sure that you have that correct. And then for the last problem, number 12, you should have -1 is less than or equal to x is less than or equal to 3 with the matching graph and interval notation. So if you have any confusion on these and any questions, please come to class with clarification. Remember, I do not expect you to come to class as an expert. I do expect that you come to class with questions so that we can go through it and clarify it.